Hi, grade 9s. Welcome to the tutorial video for the practice exam for Unit 5. As always, I'm going to recommend that you do the review in the textbook. Those questions are available on Blackboard. And also do this exam before you look at the answer key or before you watch this video. So please make sure that you prepare for the exam appropriately. This practice exam is not meant to teach you the concepts. It's meant for you to have one last chance to check to make sure your understanding is correct for the exam. So I'll get right to it here. It's going to be the same format as other exams. There's going to be multiple choice, and there's going to be short answer, and there's going to be some sketching. For some reason, I've got the part B in front of the part A here, so we'll do the multiple choice at the end. But let's go. All right, part B. Do not use a calculator. You won't need to use a calculator. You shouldn't need to use a calculator using the numbers that we're using. So, make sure my pen's working. It says express each answer symbolically. Okay, remember this is no sketches, right? You don't need to sketch these with the algebra tiles, you just need to solve them numerically. So what we've got here is we've got to identify like terms, and as I've shown you before, I always like to put sort of different little symbols underneath so that I can identify the like terms. We've got a k here, and then we've got two constants, so I've just separated them out using these different little notations. You don't have to do that. I just find it helps me keep all the like terms straight. So I've got negative 2k, and then I've got a positive 4k, so that's going to leave me with a positive 2k, and then I've got a positive 5 and a negative 6, which is going to evaluate to a negative 1. B, I've got r squareds there, r squareds there, I've got r's there, and then I've got 1's there, and an 8 there. Those are both constants. So you always start with the highest degree, which would be the r squareds. 2r squared minus 3r squares is going to leave us with a negative r squared. And you can also cross these out after you're done with them, so you just make sure that you hit every term. I've got a negative 4r and 2 more negative r's, so that's going to be a total of negative 6 r's. And then I've got a positive 1 and a positive 8, and that's going to be a positive 9. We've got brackets here. Okay, it's not going to matter because we've got, the brackets aren't going to matter because it's addition in this case. So we don't need to worry about it. I can just drop the brackets right away. Remember, if it's subtraction between the two, then you can't drop the brackets so easily. You have to distribute the negative. So I've got x's there, and then I've got constants here. So 3x plus 2x is going to be a positive 5x. And then a positive 4 minus 2 is going to be a positive 2. Over here, I can't drop this bracket because it's really like having a negative 1 in front of this one, so I'll have to distribute that negative. So I'll kind of do that all in one step. I'll drop the first bracket, because I can always do that. And now I'm going to apply this negative to both of the terms. So it's going to be minus 2y squared, and then minus 4y. Now I can group my like terms. So there's a y squared, and there's a y squared. There's a y, there's another y, and then I've just got the one constant there. So let's start with the y squareds. I've got a positive 4y squared and a negative 2y squared, so that's going to leave me with 2y squareds. Right? 4 minus 2. I've got 6y minus 4y, so that's going to leave me with 2y. And then I've just got the plus 9 left over. Drop down one more question here. All right, we've got the plus here, so I can just drop the brackets, no problem. I got 5x minus 6x squared plus 8 plus 2x minus 6x squared. There's a 6x squared, there's an x squared, another x squared, there's my x's, and then I've just got the one constant. So start with my x squareds. I've got negative 6, and then I've got negative 6 more. So I'm going more negative, so that's negative 12x squared. Get rid of those. Then I've got a positive 5x and a positive 2x, so that's going to leave me with 7x positive, and then I've just got the plus 8. This one's got a negative sign, so right away I'm going to know that I have to distribute. So I'm going to drop the front brackets, which I can do. There's nothing out front here. Minus 6y plus 3, and then I'll apply this negative through. So I've got a negative times a negative, which is going to leave me with a positive 2y squared. I've got a negative times a negative 3y, which can be positive. Remember, when you're got a negative out front, it just flips the signs. Okay, as long as there's no coefficient there, if it's just a negative sign, basically you're just taking what's inside the brackets and you're flipping the signs. I got a negative 2y squared. There's another y squared. There's a y. There's a y. And then the last one is a constant. So I'll just make a different symbol. Negative 2y squared and a positive 2y squared. Well, that's easy. That just cancels out. I've got a negative 6y and a positive 3y. So that's going to leave me with negative 3y. And then I've got a positive 3 plus another 3 is going to leave me a positive 6. Now we're doing multiplication. Okay, we're not separated by plus or minus. Now we're just, we've got a trinomial times a constant. So it doesn't matter if the negative 3 is written out the front or at the back. Okay, multiplication, it doesn't matter what order you do it in. You have to just make sure that you remember to distribute the negative 3. And if it makes it easy for you, it's no problem for you just to quickly swap it around and put that negative 3 out front. If that makes it easy for you, no problem. So I got a negative 3 times a negative 4 is going to be a negative 12. I've got a negative 3 times a 3f is going to be a positive 9f. And I've got a negative 3 times a negative 2f squared. Negative times negative will be a positive 6f squared. And we always like to write these in terms of biggest degree to smallest degree, right? The degree of this is 2, the degree of this is 1, and the degree of the constant is 0. So 6f squared plus 9f minus 12 is actually the proper order to write that in. All right, now we've got a division question. I like to write these in terms of a fraction. It just makes it easier for me to divide. But if you don't like writing it as a fraction, just make sure that you remember to divide everything by negative 3. So I'm just going to write this a slightly different way because it makes me happy. 12p squared minus 18p plus 24, and then divide that all by a negative 3. So I'm just going to draw my little arrows. You don't have to draw the arrows, I just find it helps me. I've got a 12 divided by a negative 3, that's going to give you a negative 4p squared. Can't do anything with p squared, there's no variable down here. Negative 18 divided by negative 3, well, that's going to be a positive, we know that, and it's going to be 6. There's a p here, no p there, can't do anything with a p. And then we've got a positive 24 divided by a negative 3, so that's going to be a negative 8. The last one here, just remember to distribute. So that's going to be 3 times 4 is 12, and m times m is m squared. And then for the second term, we've got 3 times negative 2, so that's a negative 6. And there's an m, no m over there, so we just have to leave the m. This one, same thing, just make sure you distribute properly. We've got a 9 divided by a negative 3, so that's going to leave us with a negative 3. And then we've got a y squared divided by y, which is just going to be a y. We've got negative 6 divided by negative 3, that's going to be a positive 2. And then we've got a y divided by y, which just cancels. So that's our final answer. Don't forget I think I did this in one of the lessons as well, y squared over y is really the same thing as writing y times y over y. And then if you see it this way, it makes a lot more sense that you can cancel one of these, because y divided by y is 1. You're left with 1y, which is just y. So we got to make sure that we know how to cancel using our exponent rules, or laws. A large white square represents an x squared tile, a black square represents a negative x squared tile, and so on. So we've been doing that the whole time, right? We've been shading in our negatives. What we're going to do is going to draw the polynomials corresponding algebra tile model. I probably won't have this many questions about this on the exam, because I figure once you can do it once or twice, you should be good. So x squared is going to be one big rectangle, negative 2x is going to be 2 shaded in, or sorry, one big square here, 2 shaded in rectangles, and the positive 4 little squares. This one, negative 6 plus 3x squared, let's write this the proper way. 3x squared minus 6, so we're going to have 3 big squares to represent the x squareds, right? You don't have to write this in there, but sometimes I do. Minus 6, so that's a constant, there's no variable, which means it's going to be shaded in tiny squares. What is that, 5? One more. All right, next one. Again, let's write this in the proper form. Negative 3s squared minus s minus 6, right? Degree of 2, degree of 1, degree of 0. And then the tile model for this, we've got negative 3s squared. So those are the big squares, and they are negative. So they shall be shaded. Then we've got 1 negative s, so there's our 1 negative s, and then we've got 6 negative constants, so these are all negatives in this question. Therefore, they are all shaded. And last question, negative 5p plus 8 is already written in the right order, so let's get our negative 5p's. 5, 1, 2, 3, 4, 5, good, and they're negative. So let's just scratch those in. And then our 8. Yeah, that's 10. Got ahead of myself. All right, so there's our negative 5p's. There's our positive 8 constants. And again, I probably won't have that many of these questions on the exam because you should be able to demonstrate within a couple if you know what you're doing or not. 2d times 3d. Sketch the expression with tiles and answer symbolically. So I'll just put all this symbolically over here. And we'll sketch the tile here. So if we're doing multiplication, remember we've got to draw our little tile model. We're going to have 3 d's on the top. These are each d tiles. And then we've got 2 d's bottom. And what does this equal when you put them all together? Okay, tall edge and long edge. It's going to be a big square, big square, big square, big square, big square, big square. Everything's positive, so we don't shade them in. And these are all going to be d squared. So if we look at this symbolically, it's 2d times 3d. It's really only one step. 2 times 3 is 6. D times d is d squared. So do we have 6d squared tiles? We do. Checks out. 12d squared divided by 3d. So let's just draw. We're doing division now, so we're kind of working backwards. You're dividing by 3d's, so let's put the 3d's up here. There's 1, 2, 3d's. And then we know we need to have 12d squareds. So if we're going to have 12 big squares, I can already see I'm going to run out of room. That's halfway done. Sorry, going to make question 3 look pretty ugly for the meantime. Big squares, big squares. All right, so what did we end up on this side? These are all d squared tiles, so we've got 12 of them. And we've got our 3d squares up here. D, D, D. Now, we have to figure out what's over here. Is going to be our quotient. So in order to make a d squared, you need a long d here, and you need the height here, which means this is also going to be a d tile, a d tile, a d tile, and a d tile. So what we're left with here is 4 d tiles. And if we do it symbolically, 12d squared divided by 3d, and 12 divided by 3 equals a positive 4, and d squared divided by d equals d, which is exactly what we had over here. So that one checks out as well. You're probably going to see tougher questions than this on the exam, but not tougher than what you saw in the assignment or the textbook questions. All right, 3, answer each of the following based on the diagram below. So we've got a triangle here. I'm going to say straight up front, I didn't bother to check. We'll just pretend this isn't a right angle triangle because I didn't check to see if a squared plus b squared actually equals c squared. I didn't do it. So anybody who's planning on crunching that out, you can let me know if that does actually work out. I suspect it doesn't. We're dealing with perimeter, so whenever we deal with perimeter, we need to be thinking about that's a fence around it, right? So let's write an expression for the perimeter of this triangle. Well, if we're putting a fence around it, we're just adding all of them together, right? So it's going to be 2y squared minus 3, right? Plus the second side, which is y squared, plus y plus 5, plus the third side, which is 2y squared plus y plus 5. We don't need to do any Pythagoras or anything. We're just dealing with perimeter. We're not dealing with area. Now, if we're going to simplify this polynomial, let's just identify And let's identify the like terms. I've got 2y squared there, I've got a y squared there, and I've got a 2y squared there. All right, and then I've got a y there and a y there, and then the rest are all constants. So if we're going to simplify this, let's start with the y squareds. We've got 2y squared plus y squared is 3y squared plus 2 more is going to be 5y squared. Okay, so I'm just going to scratch those out. Actually, I can't scratch those out because I told you to leave. Otherwise, I wouldn't be able to tell if you did the A question right. All right, so what was that? 2y squared. So I won't cross them out, but I did use them. Now let's go to the y's. We've got 1y and we've got 2y's, so that's going to be a positive 2y. And now we have to go to the constants. Negative 3 plus 5 is going to give us a positive 2, plus 5 more is going to give us a positive 7. So we'll determine the perimeter if x equals 2. Well, should have changed that. That should be y equals 2. It'd be tough to substitute an x in there. There isn't one. So determine the perimeter if y equals 2. All right, well, we've got 5 times 2 squared plus 2 times 2. By the way, I'll try to go fix this on the practice exam before anyone does it. Okay, there we go. I'm going to just take this up over here. It's going to be 5. Remember, order of operations, got to do the exponents first. So it's going to be 5 times 4 plus 2 times 2 is 4 plus 7. It's going to be 20 plus 4 plus 7 is 11. It's going to be 31 centimeters. Not centimeters squared. It's perimeter, right? And then the last question, let's express just symbolically. These are FOIL questions. We didn't do FOIL. I'm going to show you how to do FOIL. I'm not going to have it on the exam, though. All right, FOIL is first, outer, inner, last. Okay? I can't believe that it's not part of the grade 9 curriculum. As far as I know, it always used to be. We always got taught it in grade 9 when I was a youngster, a long, long time ago. What FOIL means is you do the first terms, then the outer terms, then the inner terms, and then the last terms. Okay? So our first terms, okay, are x times x. Those are the first in each of those groups, each of those brackets. So x times x is x squared. Okay, now we do the outer terms. So the outer terms are going to be the x and the negative 2, right? The furthest out. So that's going to be negative 2x. Then we do the inner terms. So those are the ones that are on the inside. So that's 1 times x, which is x. And then we've got the last term. So the last term is a 1, a positive 1, and a negative 2. And it's all multiplication. Should have mentioned that too. All multiplication. So, 1 times negative 2 is a negative 2. And then the only thing we have to do is we have to simplify in the middle because those are like terms. So that's going to be x squared minus 2x plus x is just going to be minus x, and then minus 2. So we'll FOIL these ones too. We've got the first term is 2x times x, so that's 2x squared. Then the outer terms are 2x and 1, so that's 2x times 1 is just 2x. Then we've got the inner terms, which are negative 3 and an x, so it's negative 3 times x, negative 3x. And then the last term is negative 3 times a positive 1 is negative 3. Then we just got to simplify those ones, right? 2x squared, 2x minus 3x is a negative x, and then we're just left with minus 3. Multiple choice. A large white square is an x squared, and a black rectangle is negative x. So just like we've always done, write the polynomial represented by this set of algebra tiles. Well, what do we got here? We've got negative 3x squareds. We've got 3 positive x's, and we've got 3 constants. So which one represents? Well, it can't be that one, can't be that one, and it is that one. So it's C. How many terms are in the polynomial? Well, this is 1 term, and this is 2 terms. So that's B. Which of the following is a monomial with degree 2? Well, this isn't even a polynomial because it's got a variable in the denominator, so we can just cross that one off. Monomial only has 1 term. Well, this has 3 terms, so it's gone. This has 2 terms. So this is the only one that's applicable, and does it have a degree 2? Yes, exponents 2, degree 2, A. in the coefficients of the variable in the polynomial 2x squared plus 4x minus 5. Remember, coefficients are only are what's in front of variables. So there's actually two of them here, right? The 2 is a coefficient and the positive 4. So hopefully there's one that says 2 and 4. That is B. It's written backwards, but it's the same thing. Identify the polynomial that is equivalent to this. Well, we should always be writing these in decreasing degree anyway. So negative 7v squared, because that's the biggest degree, minus 6v plus 4. So hopefully one of these matches that. Clearly not that one. Negative 7v squared minus 4, that's not the one. Minus 6v plus 4, that's the right one. From the list, which terms are like 2x squared? Well, it's got to have an x squared. Right? Anything that's got an x squared. None of these do. Only one of these does. Well, none of those do, which leaves those ones. Write the perimeter of this rectangle. Okay, so the perimeter, this is going to be t minus 1, same as this side, and this is going to be 8t plus 7. And my pen's decided to desert me. It usually does at this point in the video. 7. Okay, so what we've got here is, let's just add them up, right? Perimeter is just addition. 8t, 9t, 10t, 18t. 18t. And then let's look at our constants. We've got 7, 8, 15, 16. Is this plus or minus 1? Oh, sorry, those are minus ones. Minus 1. Sorry, I'll do that addition again. 7 plus 7 is 14. Minus 1 is 13. Minus 1 more is 12. So 8t plus 12, which is not in the answer book. Might have to change that one as well. I think B was supposed to be plus. I will change that as well in the practice exam. Which of the following expressions are polynomials? Half x is actually okay. Fractions doesn't immediately prevent it from being a polynomial. It's only if the variable is in the denominator. Okay, well, anything with a square root is out, right? That one's out. Anything with a decimal or a fraction in the exponent is out, so that's gone. And 3.5, that's actually okay. It doesn't necessarily need to be a variable for it to be a polynomial. It can just have the constant. So what we're thinking is 1 and 4, which is C. Which of the following expressions are monomials with degree 1? Well, this is a binomial, so it's out. This has degree 2, so it's out. Degree 2, that's out, which leaves us with D. Name the term with degree 2 in the polynomial 3x squared minus 2x minus 2. Well, that's degree 2. So the term is 3x squared, which is C. Okay, so I would say we noticed a few mistakes along the way. Double check my answers and make sure I didn't make any mistakes. But armed with this, you should be good to go for that unit exam. I'm not going to include the FOIL questions on the unit exam, but you're going to see those in math a lot. So, now you know how to do them. So that's great. And I will say that you're probably going to have a couple of the sketch and symbolic questions that are a bit more difficult than this. Even the examples we did with the videos were a little bit more difficult than this, and we'll probably include some negative terms. So make sure you've practiced the practice questions from the textbook. That'll be about the same level of difficulty on the unit exam. Any questions prior to the unit exam? You know our email. Please try to get a hold of us, and we'd be happy to help you. Best of luck.